Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our day. This is the end of day one. Oh, stop it. This is the end of day one. Now let's move on to day two of lesson 4.3.1. And we're on problem number 72. So it says, put these tiles pictured in each collection below on your table. You can't do that, but what you can do is, once again, go to the online tool. Here's problem 72A, problem 72B, and then problem 72C. You can manipulate all of these all you want by accessing those student tools. And what we want to do is let's put them all together. So is the direction saying to then work with your team to find the area? Okay, so I would rather you not spend the time to write this as x squared plus x plus x plus x plus blah, blah, blah plus x. It's terrible. That's a nightmare. Don't do that, please. Make your life easier. Let's go straight to combining like terms. So let's go ahead and put all the x squareds together, put all the x's together, and put all the ones together, then count them all up, and decide what the simplified expression will be, okay? And then we will reveal the answers in a moment, okay? So you go ahead and do that, and then do it for all three problems, and then pause when you are, or unpause when you are ready, and we'll reveal the answers, okay? Okay. All right, so, I mean, you don't actually even have to really manipulate the tiles. I mean, you could just do this. You could just say, well, I've got 1, 2, 3 x squareds, right? So let's write that down. And then how many x's are there? 1, 2, 3, 4, 5, 6 total x's. So we would write that as 6 x's. And then how many ones are there? Well, we got 5, 10, 15, then 16, 17. Looks like a total of 18 of them to give you a total of 3x squared plus 6x plus 18. Now, this is what it would look like by the time you rearranged all these guys and put them all together, right? You can verify you got 6 x's, 3x squareds, 15, 16, 17, 18 ones. All right, now when we look at the next collection, you got 1x squared, you got 1x, and you got 2 ones, right? So put them all together, you got x squared plus x plus 2. Okay, if you were to look at that on the online tool, we would have separated them, put the 2 ones together, but there's no matching x, so that guy stands by itself. The x squared stands by itself, and then these guys, you put them together, x squared plus x plus 2. Oh, there's the answer for that one, sorry. And then this one, you got a total of 3 x's and 3 ones. You get the idea, right? So 3 x's and 3 ones, put them all together. That is your simplified expression. So this process that we're using there is what we refer to as combining like terms. And I just did it with the online tool, so I don't have to do it again here. All right, now let's discuss perimeter of these shapes. The perimeter of each algebra tile can be also written as an expression using variables and numbers. It says here, write at least 2 different expressions for the perimeter of each tile shown at the right. Okay, so I would like for you to take and in your journal for problem number 73, draw a single unit tile, label it as 1. Draw a single X tile, which is a skinny rectangle, and label that as X. And then a medium-sized square, call it X squared. Okay, and for this, if we're going to find the perimeter, remember the perimeter is the distance around the shape. So you might want to label each one of these side lengths. So that would be, what's the perimeter of that? We'll get there in a second. Label each one of these side lengths. Maybe I'll change the color so they don't bleed together. This would be a 1. That's an X. This is an X. And this is a 1. I'm going to give myself a little more room here. And then for the X squared, do the same thing. But this is an X and an X and an X and an X. So go ahead and write down 2 different expressions. Let me model it for the first one. First off, you could say that is equal to 1 plus 1 plus 1 plus 1, right? This is bugging me. Hold on. Here. Oh, that did not help at all. Sorry, hold on. There, good. Okay, get out of there. So you could write it that way, but it'd be so much easier to just say it's 4, right? 4 square units. Let's just call it 4. We don't need to say the square units for now. All right, so go ahead and write these each 2 different ways. Pause to do that, and then unpause when you're ready. I'm just going to go ahead and write them in now, because I'm assuming you've paused and you're not cheating. So the perimeter here would be x plus 1 plus x plus 1, but it'd just be so much easier, right, to just call it 2 x's plus 2. And then this one could be, the perimeter would be equal to x plus x plus x plus x, but really you just got 4 x's there, right? So can we just call that 4 x's? Okay, so you know that this is like a multiplication statement. Remember how we talked about how multiplication is repeated addition? Well, how many x's are being repeatedly added? 4 of them, so that becomes 4 x's. Here you had 2 x's plus 2 1's, so 2 times x plus 2 times 1. Well, I know 2 times 1 is 2. I just don't know what x is, so I can't say what the answer is, so I have to just call it 2 x's. Okay, so it says, which way of writing the perimeter seems clearest to you? What information can you get from each expression? Well, the clearest one is when you write it in simplest form, right? And what information can you get from each expression? Well, you find out how many total x's there are and how many 1's there are in each one of these expressions. So here is a tile figure. Please copy this down in your journal and look and see what Liana and Jonah wrote. Liana wrote for her perimeter that the collection of these tiles was 2 x's plus 1 plus 1 plus 1 plus 2 x's plus 1. Jonah said it was 4x plus 4. So how are they different and which one is right? Which one is the correct perimeter? Go ahead and you figure out what the perimeter is and decide why you think Liana would have written it this way and Jonah written it this way and which one of them is correct. Go ahead and unpause once you've drawn your conclusion. And then go ahead and answer D as well. Which expression represents the perimeter? I guess that's what I just asked, right? Okay, bye. All right, so what do we have here? 2 x's, 3 1's, right? Those are the 3 1's, these 3 here. Here are 2 x's right there. And here's another 2 x's right there. And then here's another one right there. So she's got the perimeter right. But then so does Jonah, right? Because he's got 1, 2, 3, 4 x's and 1, 2, 3, 4 1's. So in essence, one of them is in simplest form and one of them is not. Jonah's is the expression that's in simplest form. So which one would represent the perimeter? Technically, they both do. It's just Jonah, this has been written in simplest form. It's a lot easier to write this one than it is to write that one. All right, so the expressions that you have written to represent area and perimeter are made up of terms, just like we did when we were adding numerical expressions together. Okay, so write an expression for the perimeter of this figure here at the right. Go ahead and copy that down. Label in all your x's. In fact, I'll help you out with this right now. This is an x, this is a 1, this is a 1, this is an x, this is a 1, this is a 1, this is a 1, this is an x, this is a 1, and this is an x. So I like to think of me, taking a little walk around the perimeter of this guy. And so you just get each one at a time, write out an expression for the perimeter, and then calculate how many x's are there and how many 1's are there. And then we'll use that to write our simplified expression. Did you pause and then do all the work and then unpause? I hope so, because I'm about to reveal the answer. This would be one way that you could write the expression for the perimeter. You could start with the x, then 1 plus 1 plus x plus 1 plus 1 plus 1, right? Those are the 3 1's, plus x plus 1 plus x. So a total of 1, 2, 3, 4 x's accounted for here, 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 and here. And a total of 1, 2, 3, 4, 5, 6 1's accounted for here, 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 and here. So we have a total of 4 x lengths and 6 unit lengths. So we would combine those terms and rewrite that as perimeter is equal to 4x plus 6. That is the concept of combining like terms to simplify an expression and make it easier to read and easier to know what you've got, right? So this literally tells us you got 4 x's and 6 1's, but we're just going to call it 6. And that does it for our lesson. Hooray! Today's lesson was much shorter than most days. It was much better. All right, let's head over. There's probably going to be a check for understanding after this, and then some homework to work on. All right, take care. Bye.
Hey, feeling good, like I should.